All right. Thanks again. I know it's been a long day. It's been a long weekend, but you guys have done a heroic job. And it's going to be a fantastic closer here from Agus Sudjianto. Sorry, I don't mean to. It's sort of mean, right? I should downplay it, and then you'll blow them away. No, but I know it's going to be good, so I can say it. All right, so I'm going to pass things over to Dr. Sudjianto.
Thank you so much. So I'm standing between you and the reception, and some of you between you and your flight, probably, including myself. So let me give a little bit background myself, so because that will set up the topic and the conversation that we're going to have. So I did my PhD dissertation way back in the early 90s, the early days of neural network at that time. So I wrote my dissertation is in the in autoencoder back in the early 90s. And of course, when you graduated with machine learning at that time, no such job as machine learning engineer, no job for data scientists at that time. So I designed real machine. So I worked for motor company designing car engine for Ford Motor Company for 12 years. Then I went to banking for the last 20 something years in risk management. So my specialty is really risk management. And why I retired from banking last year. Now I'm doing many different things, something that fun. Part of it, I'm serving as a executive in residence at University of North Carolina in Charlotte. I do a few advice as an advisor for startup, AI startup in Silicon Valley, and I do as well as senior advisor for McKinsey. And I, of course, I have my own startup as well. So when you work for a company, you work for a company. When you retire, suddenly you work for 10 different companies. That's what happened here. The reason I give you this background is because the presentation that I have, it's very, very heavily influenced by that. First is my love about machine learning, because that's my PhD and I have second chance in my life to work on that field again when I left behind that field for many, many years. Secondly is the risk management side. So that is something that I'm very passionate about. Those reflected in my presentation, and I make a career out of this in terms of making models safe, understanding risk in model. And because my background in the industry, it may be my perspective may be a little bit too narrow for many of you who are thinking about big idea in the society and all of those things. So my example, my focus, it's really with a lot of example in more focus on the how the industry using it, how the industry managing the risk and understanding the risk. It's one thing that I would like to start with. I'm going to start with a little bit history, what we call, some of you may not be familiar with this, is the document called SR 11.7, SR 11-7. So you Google it, you should find it. So some of you that remember in 2008, the financial crisis of 2008, one of those, the one that get the blame at that time is a model that really creating havoc of the entire economy of the world. That was the infamous Gaussian copula, the how people pricing derivative mortgage-backed security. That's what creating a havoc at that time and humongous financial crisis in the world. So since then, Federal Reserve publishing what is called SR 11.7, guidance of how to manage model risk. This is way, way before we talk about responsible AI. So since 2011, 2012, when we started, every bank has to have something that called model risk management. You have to govern the model. You have to understand that model inherently are risky, and you have to understand the risk and how to manage it. So the three components that's very important in there is, of course, is the practice of model development and implementation. And then something that called model validation. This is interesting, we talk about it today, but the setup, this is what the third component is, governance, and all of this is very important. In financial institution like bank, it has somebody as a chief model risk. So I was one of those before I retired. I report to the chief risk officer who report to the board directly. So the stature of somebody that responsible for the use of model in the bank is a very, very senior. And bank like Wells Fargo has a few thousand models. And we know them all. We know the health of them all. We test them all. We document them all. It's because it's regulated. So so that's the situation. So you have very senior people that anything wrong with the model, the head will roll first. And it has the authority to say, stop, you cannot use this model. So I'll share with you a little bit story I shared with some of you during this conversation. When COVID-19 hit, the head of innovation said, okay, we're going to use an AI model, epidemiologist model, to make decision whether a bank branch will open or close, right? So they're going to use that model. It came to my desk. I say, not a chance in my life. You cannot use that model. Don't even think about it. Because we know what happened. We know which branch that we're going to close. I said, I know you're going to close the branch in Bronx. I know who's going to get disadvantaged. But because of the governance, you have somebody who can say no and stop. Don't even think about it. That's the power of something that regulator help us to grow model risk management. So many, and this is not a theoretical thinking or wishful thinking about responsible AI. This is day by day that the industry has practiced for the last 12 years. So I think something that worthwhile to look at how bank practice on model risk management. And this is one of the things that very foundation in the model risk management in the second point in the previous slide is model validation. And model validation is independent model validation. Those are the people who report to me. I cannot build model. My team cannot build model. The business build model. We can stop model. We have to test every single model. And for every 3 data scientists that build model, 1 independent model validator. So you think about it in Wells Fargo, we have 340 people that day in and day out, hacking the model, testing the model, understanding that. Why is this so important? I talk about the financial crisis. We don't want to have a financial crisis again, but we also have a lot of stuff that's super important. For example, credit underwriting, approving credit. So yes, we have to think about the risk about people not paying. That's one thing. But also we have the risk of unintended consequence, the bias, the fairness that we have to address. Something that very mundane when in terms of model. When you lost your credit card, you make a phone call to the company and somebody will answer your call. In your call will be listened to our machine learning model and looking at what is your phone line, where are you calling from, your voice, your background noise, and in front of the person who answered your call, it has fraud score. What happened if somebody that speak with accent like me, or like many people speaking with Hispanic speaking, get fraud score that higher? Model can be easily discriminatory. We do large bank like Wells Fargo. We receive complaint all the time, right? A million complaint a month, more than a million complaint a month, process complaint and inquiry and all those, about 1 million. And every single one of those has to be processed and resolved within 10 days. The only industry that have rule that any complaint has to be solved within 10 days. No other industry. If you have a problem with your cell phone, or you have a problem with anything, good luck, right? But with bank, has to be solved within 10 days. So what happened with that process? How to process this? You have phone call. The phone call has to be converted from voice to text. And then text will be processed through our language model to say, is this a complaint or not complaint? And route it to the right people. Because the cycle is only 10 days. So what happened in voice of the text? When for some people that speak certain language, particularly the Oriental language, a lot of transcription is missing. When transcription is missing, complaint can get misdetected. Complaint can get misrouted. So all of those things has to be tested. So it's not only how accurate the model is, but we have to think about what can go wrong with this model. So I'm very pleased actually that my presentation is the last day and the last presentation, because I had opportunity to listen to many of the talk and people, and this is one of the problem. I think this is for Dr. Coffee too, because teaching machine learning. The worst thing that machine learning people do, they teach you how to build the best machine learning and measure it with a simple metrics. AUC, MSE, and all of those things. Those are the worst metrics to focus on. Yet the culture is like that. The university teach like that. So it's a big problem, and I'll go into a few examples of that. Why that we have to change it. We have to change the way we teach. And I'm going to use a very simple example here to illustrate. And I'm going to a few things. So it's very, very simple. We're going to predict credit default or no default. I'm using tabular data here, but we can talk. I will talk about language model as well later. It's very simple variable: employment. Are you working for a company or you're self-employed? Income, debt to income, credit score, the amount of loan, the tenure, how long the loan, employment length, or how long is in the business, delinquency, the historical, how many times you make a late payment, the amount of saving, and the credit utilization is just default into default. So very simple. So something like this, you learn machine learning, you build machine learning to predict. Apply gradient boosting machine, apply neural network, very simple, right? So what we did. So what happened? We applied gradient boosting machine, okay? The AUC, for some of you, AUC is from 0 to 1. When you have 1, you have perfect model. When you have 90% like that, 0.9, you have fantastic model. And you're done. You have fantastic model. But what happened with that model? When you look at the credit score, the effect of credit score, that's the chart at the bottom. The higher the credit score, the low probability of default, which is correct. But what happened? The lower credit score is also lower probability of default. The model doesn't make sense. Nonsense. The model is completely nonsense. So you can have very high performing model, but the model completely make no sense. That's happened all the time in machine learning. Happen all the time. And this can be very hurtful. And this is one of the things that create harm, because your model doesn't make sense at all. So this is where the interpretability, explainability is so important. Build machine learning as much as possible. Strive for interpretable machine learning. It doesn't mean that you have to use very simple logistic regression. By the way, I'm using gradient boosting machine, but I construct it in a way using functional ANOVA that I control the architecture so that I'm still using gradient boosting machine and I can still use neural network, very high performing, but inherently interpretable. And I'm not using interpretable. Many people in this field in selling snake oil, by the way, it's called XAI, explainable AI, using tool that call post hoc explainability. Is a lot of alphabet soup like there. It's very popular technique, lime chap, and all of those stuff. It's a lot of snake oil in explainable AI. If we're dealing with tabular data, I'm not talking about language model. I'm talking about tabular data. It's no excuse, especially in high-stake environment like approving credit. It got to be inherently interpretable. It doesn't mean it's logistic regression. It can be gradient boosting machine. It can be neural network, or even more sophisticated combination of that. They call mixture of experts. So visit that website if you're interested in to learn more on that. Here's the second thing. People talk about performance. So what happened is we fix it. First is we fix it. Okay, we need to make it monotonic. Now the effect makes sense, monotonic. So we can control monotonicity. So when using machine learning, we have to control the behavior. We have to control the shape. We have to control the monotonicity so that the model makes sense. Now the model makes sense because the lower credit score, more probability of default, higher it will be less default. But we get hit with the performance. The performance get hit very significantly. And what really the other piece that's important is people look at AUC, well, we get hit by the performance, but still acceptable. Okay, we are done. Well, wait a minute. This is exactly what the problem that we talk about. If we look at the error, the top right distribution, so we cluster the data. We cluster the data and we look at what is the error in each cluster. Very, very different. Some cluster, the model is terrible. And this is what's interesting for many of you that's building model. I build model, I get humble all the time in every credit cycle. I will tell you the real thing. Model work when the business don't need model. Model don't work when the business really need the model. Every single time. During the financial crisis 2008, when we need to, what we need to do here with all these things, no model work. Then in 2010, I went to Europe as the head of analytics for Lloyds Banks, the largest commercial bank in UK. Euro crisis. When we need the model don't work. Okay, and that's not long ago. In 2020, COVID hit. We need model don't work. Every single time. When economy is good, we don't need credit decision model. Just approve everybody, and you will be okay, right? So this is the reality. And this is why exactly because people miss to understand in what area, what condition your model don't work. That's the first thing that we need to do. We have told how to do it. So looking at the aggregate metrics is the worst sin. So I don't mean to single out one of the presentation on the first day, and I questioned that. One of the presentation talk about F1 score for criminal justice system. That's not the point. The point, tell me in what segment, what condition that your model is not working, because that's when the harm happened. So that's the key. Yeah, so that's one of this. This is only number 2, by the way. Yeah. Number 3, harmful side effect. Sometimes we get excited. Oh, we know this factor is very important driving the output. Do you know that factor also driving the error? Do you know what variable driving the error? Machine learning class don't teach this. So we can do it. So I'm giving example here. I'm building a second model, inherently interpretable. I'm using XGBoost. I replace the output. Instead of the original target, the output is my residual error of the model that I have. So I can find in the mid score right there, I have spiked. My model is terrible in that region. And what is driving the error? I know exactly what variable driving the error. Because that's when you know what is the, try to identify what is really driving the problem in your model. Not only understanding what factor is important, understanding what factor that make your model wrong. Super important. That's number 3, by the way. Number 4, miscalibration. Every machine learning miscalibrated. Every single one of them. So if you try to make decision based on the probability, all machine learning has miscalibration of probability, all of them wrong. So you have to calibrate it. You have to do calibration. And this is an example here. The top chart is called Breyer score, which is the actual value minus the probability predicted by machine learning. And you can see as well, some region, the error is so terrible, the terrible decision right there. If you make decision to provide treatment or not to provide treatment, providing loan or not providing loan, sending people to jail or not. That is a very dangerous area there on the left. Need to understand what condition. So miscalibration is very, very important. Well, and by the way, we talk about machine learning, people like to talk about AUC, area under the curve, is basically doing ranking. How good machine learning to rank ordering from the bad to from good to bad. Very good. And you look at it, if you look at all the way on the left on the second chart, the AUC is 0.2. By the way, AUC 0.5 is random decision, toss a coin. 0.2 is worse than random. Your model wrong all the time, almost all the time. But remember, the overall was 0.8, right? Before, the overall was 0.8. That's so good model, 0.8. Yeah, but you have a region that your model wrong all the time. So that's why never look at that, and particularly have to do probability calibration, because every machine learning wrong when you talk about probability. Now, what is the consequence of this? One of this is this: performance fragility. Because when you deploy model, the world changed, the world's shifting. So if you look at it, if it's shifted to more, we have more customer or more cases that in a region that really bad, your model performance will be getting worse and worse and worse. Your model is very fragile to any usage changes. So that's the outcome of that. You have model that's very fragile in terms of performance. We call it resiliency problem here. Now, the other thing is this: machine learning make decision, but how certain is with that decision? If you use ChatGPT, it gives you answer all the time very confidently. It looks very confident. Machine learning also produce output, right? Produce output, rational machine learning. The problem is not about the output. How certain are you with the output? So in this case, in this example, the decision is simple: approve or not approve, default or not default. But look at several clusters. If you look at the y-axis, the number is 2. The decision is both. The machine learning only gives you one number, either default or no default. But actually, if you calculate the uncertainty, the model is not uncertain. The model is very uncertain. It can be both. And you have a lot of things that both, guilty or not guilty. The machine learning will say guilty, but is it? How certain? So it's understanding uncertainty is super, super important. So we use typically techniques like conformal prediction that is very wonderful. So understand where the model is uncertain and understand why. Number 7. Robustness issue. This is part of it why we don't have self-driving car today. All machine learning are overfit, but we just don't see it. So this is the problem with machine learning people. I build model, I have data, I split it. Test part of it randomly, I'm using for building model, and portion for testing. And I test it. It looks beautiful. It's a big problem there. Why? Because that your testing and training has the same noise, same distribution. Real world is not. Real world is not. So when it looks good, now we drive it outside with a little bit cloudy and different thing, your model not working. So this is the robustness issue. This is the sensitivity to noise issue that we have. Okay, you have to check it and understand which situation, which group, which cluster that my model is super sensitive to noise, because decision flip very easily with small random noise. Number 8, heterogeneity. Machine learning, when people build machine learning, we typically say, oh, okay, we're going to build machine learning. It's a monolithic system. One model that rules them all. One model. It failed to account for heterogeneity in the data, and real world are heterogeneous. Remember this one here? If I go back to the beginning, the model that this model that we fixed the problem, right? The most important is score. The second is debt to income. The third is utilization. Performance is 0.8. It failed to detect the heterogeneity because actually it has two populations. People that don't have long credit history. So that is, you should not use the score. You should use something else. So different population. You have subpopulation in your data. Some are important than the other, behave very, very differently. You cannot solve it with a single machine learning. You have to at least segment it, or in this case, we're using more sophisticated technique, using mixture of experts. So understanding heterogeneity, we cannot, because population subject that you're dealing with are heterogeneous. You cannot fit one single model. You have to understand, and some clever technique like mixture of expert can detect how to segment it. So if you recall, from 0.8 before, now suddenly becoming 0.88, 0.87 on the testing, because it captured the heterogeneity. And if you look at the performance, still not very homogeneous, but way better than before. You remember before the worst one is 0.2, worse than random. Yeah, on the AUC, now it's a lot better. So understanding, do you understand the heterogeneity in your data? Do you treat that? Because single monolithic model, which every machine learning people do, are incorrect. Because people think this is our sophisticated model. I don't need to segment it. I can build single model. That is a myth that is really incorrect. Here it is. Hole number 9, disparate impact. All the model that I used before, I'm not using demographic information. I'm not. But my model can still be biased. I give example, and this is an example on this is interesting one. Again, I'm looking at the aggregate measure. In banking, we typically use what we call it measure called AIR, adverse impact ratio. Basically, adverse impact ratio is very simple. We look at the approval rate, if in credit decision, approval rate of one demographic divided by the approval rate of reference demographic, right? Females, male, Black, Caucasian, or whatever different age. So with rule 80, people do, okay, we need to be at least 80%. Everybody do that. So typically bank will do 90% instead of 80%. In this case, it looks good, close to 0.8 in that average. So we just need to nudge it a little bit, it will be okay. But the point is, you have a segment there that the model is very, very sexist in this situation. We need to know that because the aggregate number looks good. And when aggregate number looks good, always be very careful. This is the point, is finding region where you have problem. You know why? Part of it, when you deploy your model, things shift, things change. I call it shit happen. Shift happen, right? I call it shit happen. When shifted to that, suddenly your model becoming sexist, becoming racist. And if you experience this, we talk about this theoretically, and sometimes in this conference, it's kind of nice talking about this. But if you have experience like me, have to be in the court, 7 hours in a day, 3 days in a row, grilled by lawyer on the other side, from the other side, because the company is sued because of the accuse of racial discrimination, and I have to defend it. We go, hey, this is what we did. We did all this testing and all this thing. So we lay out the fact. It's very, very painful. So sometimes I look at it and say, yeah, there is a regulation, but there is also the American way. Just sue the company, okay? Right? It's becoming very, very expensive. Even that's why, even today, when we don't have CFPB anymore, we have CFPB but cripple, okay? But we still have American system, court, sue, right? So that's what happened. So this is all the thing that's super important. So I give you 9 example of model hacking here. So I have and this is one of the my favorite thing. I have a slide on this with Swiss cheese on it. I always say, does your model have more holes than Swiss cheese? Okay, I just show you 9 holes. It's more holes than 9 that I show you. But this is something because any problem with this create harm to the user or probably to the people and to the society. So please don't focus on the average model performance. Hack your model, understand what's going on. I think I still have time. So I'm going to Gen AI now. Let's do Gen AI. I call it a vibing machine, right? Gen AI is vibing machine. Gen AI is filling the blank. It's no reasoning or anything like that people claim. It's filling the blank, basically. Very useful when we want to use it for mindless entertainment, right? That's what we do all the time. We use it for mindless entertainment, creating picture, doing for PowerPoint slide, for many things that we do it. So for mindless entertainment, it's very useful. Now, we want to use it for high-stake area. We want to use it for medicine. We want to use it for healthcare. We want to use it for financial decision. Okay, we're talking about vibing machine here. We just go with the flow, right? Complete the blank, and we're going to use it. The model is designed to fill the blank. So when you complain about the model hallucinating, not giving me the right answer, you misuse the model. The model is not designed for that. The model is designed to fill the blank, not to be truthful. Now we expect model to be truthful. That's what SR 11.7 call misuse of model, by the way. And the lot of risk is about misuse of model. When we talk about the crisis in 2008, it's completely misuse of model because people don't understand what this Gaussian copula is and the limitation of this Gaussian copula, and they traded $1 trillion, right, on that. So this is what we have to deal with on Gen AI. Okay. We use Gen AI for this. This is interesting one because a lot of bank, this is it's a temptation. And I talked about complaint before, bank process complaint. So I have process like that. It's a statement from the customer, and we ask, is it complaint or not complaint? To ChatGPT. The ChatGPT said it's not complaint. It's very polite. We're just asking question. Then I asked ChatGPT again, are you sure? Then ChatGPT said complaint now. Yeah? The model is like that, behaving like that. The difference, by the way, is just I give it 2 different system prompts. And by the way, I'm using the first prompt, but I fat finger it. I tap, it has F at the end. Yeah? The same prompt before, there's no complaint. I just fat finger with F. The ChatGPT says it's complaint. You're dealing with vibing machine. And now you want to use it for real thing. That's what we're dealing with. All right. Now, testing, and this is probably, I don't know, it's a lot of people talking about, okay, let's test LLM. A lot of people, you see all those benchmark on the LLM. First of all, you're not going to accept student or hire student just based on the SAT score or whatever. Sometimes you may do. We don't hire people just based on SAT score or GPA. We interview the person, right? We want to know the person more. So all those benchmarks that are out there that talk about MLLU, Gaia, and all of those things, it's just benchmark. And by the way, those benchmarks are rigged because every model trained it using those benchmarks. So it's completely meaningless. So when yesterday Llama 4 came out with all those benchmarks, it's benchmark, okay? The benchmark number is in the training data, okay? So, but how do we test this one now? I would say testing large language model is impossible. Testing comprehensively is impossible because the input is unbounded and the output is unbounded. You cannot test the unbounded stuff. So when we want to test in enterprise world, in corporate world, in the industry, when we want to use it, we have to bound it. We want to use it for specific purpose. If we want to use it for specific purpose, I bound it. Now I can test it comprehensively. For example, many of you heard what called RAG system, retrieval augmented generation. But what retrieval augmented generation is basically give context. ChatGPT answer it only using this document only, nothing else. Okay, don't wander around, just based on this document, retrieve the information and answer it using this. So you bound it. When it's bounded, then we can test comprehensively. But still, this is challenging because unlike predictive AI, this is a big difference, right? Predictive AI is designed to produce a single output. Predicts one. Generative AI to produce many output, right? So whatever possibility. Now, but also the important thing is when building predictive AI, so many of presentation in this conference, people have data. And I split the data for testing and training. In Gen AI, we don't have that. We have to create it. We have to create the test. Now, when we talk about create the test, how can we make sure? My apology. I think somebody is your.
Somebody else. It's okay.
Okay.
Okay. Sorry about that. Now.
I'll do 3 more minutes.
All right. You're worried about you catching your plane.
Oh yes, let me do 3 more minutes. Okay. So the thing is, how can we make sure that the test is comprehensive? Secondly, how are we going to evaluate them? Because evaluation is very costly too, because humans have to do it. Can we afford, create, and perform comprehensive tests? This is the problem, the challenge that we have. Now, this is I have a paper on this that feel free to download in SSRN. If you search under my name, it has a paper on this. So the step on testing generative language model, I put a 5-step. One is test generation. We have to generate tests that comprehensive based on the topic, all the content in the document. And then the query type. What different kind of query? We'll talk about that a little bit. And then we have to be able to evaluate because we're going to test it with a lot of testing. And then we can use Gen AI to help to create query, create test cases. Yeah. So we have the document, we have the truth answer, and convert it into question. That Gen AI is very good at that, and see if the answer will get the truth, the correct answer, right? So you can do test generation, and then evaluation. And this is the worst thing that people do today. People take all kind of shortcut. People think that this Gen AI can be a judge, can be a good judge, can evaluate. Remember, I asked, is this complaint or not complaint? And people do that. It's complaint, it's not complaint, right? You say, okay, is this hallucinating or this is not hallucinating? You ask Gen AI to do that. Gen AI will give you answer. Whatever question you have, you know it's going to give answer, whether it's correct or not. And then, wow, but also the coming up with explanation. Well, the explanation have nothing to do with the answer, by the way, if some of you interested in. Read the very interesting article by Anthropic lately. And the Anthropics are talking about that, the explanation that Gen AI does, nothing to do with the answer that Gen AI gives. It just make things up, right? So we don't do evaluation with Gen AI. We need to do evaluation that's very transparent. We can see it. We can how the model make decision. We'll talk about that. And then human calibration, because the evaluation through algorithmically done, because we're going to test it with a lot of tests. But now we need to do sample it, human labeling, and we do calibration between machine evaluation and human evaluation. We can create calibration model, and we can build confidence interval on top of it, let's say using conformal prediction. So please read the paper that I have. And then one of the key things from that, then we identify in what situation the model will be wrong. Remember, when we talk about the tabular data before, hacking model, identification of model weakness, where the model is wrong. Don't look at average number. And then, of course, we need to do robustness tests. change the input query, make it ambiguous, make it differently, and all of those things. So let me stop right here because I can talk about this forever. But read the paper. Okay, so
I think we can make time for maybe 2 quick questions. And I believe that our student workers have a feedback form they want to share. And are you going to do closing remarks as well? Okay, and don't feel bad about heading to your flight after you answer questions, because we know it's coming up quick. Okay, questions for Dr. Sudjianto. All right, I see Genevieve and then David.
Thanks for your talk. Super interesting. One thing I was thinking about when you were talking about the vulnerability 9, kind of disparate impact, and something in like credit assessment and testing, disparate impact and kind of understanding. I guess I'm curious, like what exactly, do you think is the best way to test for disparate impact, especially in context of credit scoring, where it's a bit of self-fulfilling prophecy, in terms of like if you're deemed to have a lower credit score and you have a higher interest rate, then you may be more likely to default. And so then if the outcome you're testing is whether that person, whether it's fair because that person defaulted or not, but yet the interest rate. So how do you take into account interest rate in assessing disparate impact? And I guess just very curious a bit about that.
Very good question. By the way, let me tell you a bit the process as well on this, both on the model development and model monitoring. First of all, when we measure disparate impact, the US have wonderful law called ECOA, Equal Credit Opportunity Act, right? Those are the law that govern. So any credit product, be it you get offer of application to apply or approval or pricing, how much interest rate you going get apply, all of those has to be tested, cannot be discriminatory, right? So it has to be tested. And the testing, it has 2 parts. One is during model development, we have 2 groups, people that build model, and then we have independent groups that cannot get involved in model development, that the job is only testing. And by the way, people that do testing, in this situation, if it's credit approval, we compare approval rate. We compare approval rate of protected class against reference class, approval rate in that case. If we talk about declining for fraud, declining transaction, then we talk about the false negative. We're comparing false negative, right? So that's different application, different purpose. You're looking at the positive side or looking for negative side. You can use a different measure on this. So independent group, that the job is only testing for fairness. And the people that do independent testing for fairness cannot get involved in model development. It can say, you have problem and you have problem with this variable, but I cannot help you. How are you going to solve it? Because it need to be maintained independent and no conflict of interest. So that's what we do. And then ongoing basis, monthly, all the portfolio in the bank, the pricing, the approval, we test it all the time to make sure, because remember, we have distribution shift happen. So we need to check to make sure that the decision are fair all the time. So that's for credit product, yeah. But when area that has law like that, it's very, very good because make my job easy. Because it has law, you cannot violate law. So it's no trade-off between financial and this because it's law. But the more problematic and when we don't have law. Yeah, when reputation and do the right thing. Remember, I talk about COVID-19 problem. I talk about voice to text translation problem where there is no law on that. Then that's the decision that we have to make from the ethical point of view. Are we going to do it or not? But we measure it with either approval rate or denial, or depending on the situation, what is the negative outcome. Okay, go ahead.
I have a question. Oh, I think we have one question from David, and then I think maybe you can ask the question walking with Dr. Sudjianto too. The airport can be a problem.
Right, so I had to write my question down. So you did discuss the several critical vulnerabilities like the heterogeneity, blind spot, and the conceptual misalignment. So in practical development scenarios like healthcare or even finance, how would you recommend balancing the model performance with the interoperability and robustness? And then are there any
I am not asking for balancing because we can do good in all of them if you do it right.
Okay.
So when people talk about interpretability and performance trade-off, I don't believe that. That means you just because there are a lot of sophisticated tool. I talk about gradient boosting machine that can be inherently interpretable. I have a paper on this, search and archive. Yeah.
Right.
And the software, I put the software, go to modify.ai, it has that, right? So I don't believe on the interpretability on that. Robustness, yes, you do, but you have to think about, hey, real world. Yeah, real world, because if you think about robustness, how robust is against noise? You can get in laboratory, it looks so good, performance looks good. You deploy it, it's terrible. When I build engine, I'm not testing it in laboratory. I'm testing it in hot summer day in Miami and Death Valley, California, and Telluride, Colorado, in Alberta during the winter time, right? My product has to be robust because that's what real world. So I don't see it as a trade-off.